Hello guys, welcome to CleverQ. Let's quickly jump into today's topic. Today we are going to discuss about green hydrogen. So here we can see headlines of different articles saying Dubai launches region's first industrial scale green hydrogen plant, and other article says Oman to host 25 gigawatt of solar and wind for green hydrogen. And here another article says Oman plans massive $30 billion green hydrogen project. So why are countries very keen in investing into green hydrogen projects? So what are the advantages of green hydrogen? What is its importance and what actually is green hydrogen? So let's quickly look into it. So green hydrogen, it is hydrogen fuel that is created using renewable energy instead of fossil fuels. It has the potential to provide clean power for manufacturing purposes, transportation, and many more sectors. So its only byproduct is water here, guys. So what is a byproduct? So what is a byproduct, guys? So byproduct is nothing but a secondary product derived from a production process. Okay, so we can also put it in this way. It's something which is produced in addition to the principal product. Okay, guys. So next, hydrogen can be produced in a number of ways. One method includes using electrolysis with an electric current splitting water into oxygen and hydrogen. If the electricity used in this process comes from a renewable source such as wind or solar, then it is termed as green or renewable hydrogen. So what is renewable source? Renewable source is nothing but clean energy source. Okay, something like wind energy, solar energy, or hydro, geothermal, tidal energy, or something like biomass. Okay, guys. So next, according to an analysis by the Council on Energy, Environment and Water, green hydrogen demand could go up to 1 million tons in India across application in sectors such as ammonia, steel, methanol, transport, and energy storage. So, Council on Energy, Environment and Water is a Delhi-based research institute. So next, how is green hydrogen produced? So hydro and wind are used to generate clean renewable energy. This energy is fed into electrolyzer with water. Then the electrolyzer splits the water molecules to create hydrogen and oxygen. Then this is stored. The hydrogen gas is compressed and then stored. Once it is stored, the gas can be transported to anywhere in the world for any use, like for domestic or industrial use. Next. So look at this picture, guys. The same thing. You can see clearly how hydrogen and oxygen are split and then they're safely stored here. So look into this, guys. You can get a clear idea about the process. So next, why green hydrogen is needed? Okay, so green hydrogen will be essential to in meeting the goals of Paris Agreement. So what is Paris Agreement? What is it? So I think many of us know Paris Agreement is nothing but it aims to substantially reduce global greenhouse gas emissions in efforts to limit global temperature increase by 2 degrees centigrade above pre-industrial levels, right? Yeah. So coming to the advantages, yes, hydrogen is abundant and its supply is limitless, and also it is non-toxic. Okay, and unlike batteries, which are unable to store large amount of electricity for extended periods of time, hydrogen can be produced from excess renewable energy and it can be stored in large amounts for longer times. Okay, and coming to storage here, green hydrogen can be used in industry and it can be stored in existing gas pipelines to power household appliances, guys. And also it is a clean energy source and it is non-toxic, as we already discussed, and hydrogen greatly reduces pollution and it's far more efficient than any other source of energy, and it's very abundantly available. So green hydrogen will be essential to helping global economies to achieve net zero emissions by 2050 and limit global temperature rises to 1.5 degrees centigrade. So green hydrogen could supply up to 25% of world's energy needs by 2050. So what is net zero emissions? What is it, guys? So it's nothing but, to put it simply, net zero means we are not adding new emissions to the atmosphere, right? It's very clear. So this is why a growing number of countries are making commitments to achieve carbon neutrality, or net zero emissions within the next few decades. So it's a big task. Okay. So, considering India's 175 gigawatt target of renewable energy capacity by 2022 and 450 gigawatt by 2030, it is imperative that our energy grid involves other green technologies on a medium to long term basis. So, this will help India lower its emission intensity by 33 to 35% from 2005 levels by 2030. Okay, so which is another nationally determined contribution and target under the Paris Agreement. Hydrogen has almost 3 times the energy density of diesel or even gasoline. So, to put it simply in electrical terms, energy density of hydrogen is 33.6 kilowatt hour of usable energy per kg. Okay, so compared to diesel, which is 12 to 14 kilowatt hour per kg, which, despite having significantly lesser energy density, emits severely high levels of CO2, cobalt, particulate matter, and nitrogen dioxide. Okay, so a shift is definitely needed for cleaner energy with green hydrogen. So, next, we have already learned about green hydrogen. So, let's look into blue, brown, and gray hydrogen. So, coming to green hydrogen, this is made from renewable energy and no CO2 is emitted, right? So, and here, whereas blue hydrogen, it is made from natural gas and CO2 emissions are captured and they are stored. Okay, and wherein brown hydrogen is made from coal, then CO2 is emitted into the atmosphere. Okay, then gray hydrogen, this is made from natural gas and CO2 is emitted into the atmosphere. We can see the difference here, guys. Here it is stored and here it is emitted. Let us also quickly look into the differences between blue and green hydrogen. So, blue hydrogen is a cleaner version of which the emissions of carbon are captured and stored and then they are reused. On the other hand, coming to green hydrogen, it is produced through electrolysis, which is a process where the separation of water and hydrogen, water into hydrogen and oxygen will take place. Yeah, so let's also look at few differences between electric vehicles and hydrogen vehicles. Okay, so when coming to conventional vehicles, so they burn fuel in an internal combustion engine. So battery powered, electric vehicles don't have an engine. Instead, they use energy stored in batteries to power one or more electric motors. Okay, they're also capable of producing instant torque and smoother acceleration than conventional cars, but they are not environment friendly. If you see, like if the electricity used to charge the electric vehicles comes from a coal power plant, then yeah. Electric vehicles are also limited by the range. They can travel on a single battery charge for short distance commuting, but this isn't a problem. But for longer trips, they require lengthy periods of recharging. And coming to hydrogen vehicles, guys, fuel cell vehicles are also driven by an electric motor, but instead of being powered by a battery, they create the electricity in an onboard fuel, usually using oxygen from the air and then stored hydrogen. Okay, the main disadvantage of today's hydrogen fuel cell vehicles are the lack of sufficient infrastructure for the hydrogen refueling and the cost of the catalysts. So, guys, pure hydrogen fuel cells only emit heat and water as a byproduct. So such cells are also far more energy efficient than traditional combustion technologies. Okay, guys. So fuel cell vehicles don't have the same range limitations as battery powered vehicles because they can simply store more hydrogen fuel, right? And yeah, as we discussed, there's a lack of infrastructure. It is a big disadvantage for us. So, considering today's climate concerns and increasing focus on zero carbon renewable energy, globally it have made hydrogen based energy sources more relevant than ever today. So, strictly carbon abatement regulations have also pushed hydrogen producers to move away from conventional fossil fuels to green power sources like wind, solar, biomass, hydroelectric power, and so on. Right. So, in this global context, it is crucial for India to get ahead in the race of new and upcoming green technologies and become self-reliant. So being an early adopter of hydrogen energy technology, it will pay off in long term for our country. So India must address several challenges to enhance commercial scale operations, and India will soon join 15 other countries in Hydrogen Club as it prepares to launch a national hydrogen energy mission, which is announced in this budget. And the global target is to produce 1.45 million tons of green hydrogen by um, 2023. Okay, guys. So this is it for today. Thank you for watching.